Okay, so when we're doing linear equations, it's really important if we've been asked to graph it in y equals mx plus c, that we know what the m and what the c are. So m is our gradient, so that's our rise over run, or also sometimes call it our slope, and the c is the y-intercept. So the y-intercept is actually the easiest one for us to find. It's the place where it crosses the y-axis. So here's the y-axis running down here. It's our vertical axis, and it's crossing here at positive 3. So c for this one is positive 3, or just 3. Now our gradient, there's a couple of different ways that we can work out our gradient. I'm going to show you the easy way first. The easy way is to just say, well, every time we go across by 1, how many up or down are we going? Well, as we go across by 1 here, we are going down by 2 when we reach the next point there. Okay, so our gradient for this one, m, is equal to -2. Every time you go across by 1, you're going down by 2. Now, when we say across, we always mean across from left to right, the same way that you write. So if we've been asked to determine the equation of that line, and we've got our m and c, we simply rewrite y equals mx plus c, but instead of writing our m and writing our c as m's and c's, we write in the values that they're worth. So we rewrite that exact same thing. Y equals, m is -2, so we're going to go -2x plus c, which is 3. So that's our final answer. Y equals 2x, -2x, sorry, plus 3. And so whenever we're looking at that, we can just go, okay, well, every time we're going, we're starting here at positive 3 on the y-axis, and every time we go across by 1, we're going down by 2. Cross by 1, down by 2. Cross by 1, down by 2. Now, the other way that you might have been shown to do it, and it's a good way to know, is using the gradient formula. There's two ways that you can do gradient, is rise over run, or using a fancy version of the formula, which is y2 minus y1 over x2 minus x1. Now, it's essentially the same thing, okay? But basically it means that you can choose any 2 points on the line and you should get the gradient. So it's good to choose the y-intercept, you know, particularly if it's crossing nice and neatly here at a whole number. And then you can choose any other point where it crosses two of the lines. So we want to have whole numbers. So this could be one of those points. This one here could be one of those points. Down here could be one of those points. Doesn't really matter where you do it. So I might stick with going on this one here. And so when we look at it and we try and work out the rise and the run, our run is how far across we go. So for this one, we've got a run of 2. We've gone across by 2. Our rise is -4 because we've gone down 1, 2, 3, 4, down as you go from left to right. So if we're just simply using rise over run, we've got our rise being -4 over our run, which is 2. When we simplify that, -4 over 2 is -2, which is what we got for our m anyway, just by looking at it, by saying going across for a run of 1. Essentially what I did there is I said, okay, I chose those 2 points instead. We had a run of 1 and a rise of -2. Now the same can be done if we're using this fancy version of the formula. When we use the fancy version of the formula, we're actually labeling the points. So this point here is 0, 3. This point here is across 2 and down 1. Now, if we're going to use that fancy version, which it is nice for you to know, you would label them x1, y1, x2, y2. And if we substitute into that formula, let's look and we say y2 is -1 minus y1, y1 is 3, all over x2, which is 2, minus x1, which is 0. Now when we simplify that, -1 minus another 3 is negative 4. 2 minus 0 is positive 2. And again, simplify that fraction. Negative 4 over 2 is negative 2. So there's a few different ways that you can get your m. As I said, the easiest way is just say, as we go across by 1, how far up or down are we going? And that's how you get the equation of a line.